The use of 400-watt medium-base high-pressure sodium lights on a 30-amp circuit is a code violation. This explanation is based on the National Electrical Code, specifically sections 210.21 and 210.23b. Section 210.21 addresses branch circuits and their limitations when supplying lighting units with ballast-type lamps. The code states that branch circuits rated for either 15 amps or 20 amps shall not supply lighting units with ballast-type lamps that exceed 660 watts. This means that if a circuit breaker or fuse is rated at 15 amps or 20 amps, any lighting fixture connected to that circuit that uses a ballast, such as fluorescent or high-intensity discharge lamps, cannot have a total wattage exceeding 660 watts. Section 210.23b focuses on 30-amp branch circuits and their limitations for lighting. According to this section, branch circuits rated at 30 amps shall not supply lighting units with ballast-type lamps exceeding 750 watts. Therefore, a 30-amp circuit can only handle a maximum of 750 watts of lighting load when the lamps use ballasts. Medium-base lamps are generally designed for a maximum wattage of 660 watts. High-pressure sodium lamps with a wattage exceeding 660 watts typically use a different base configuration. This design difference ensures they are not installed on circuits that cannot handle their higher power consumption, and that the appropriate electrical protection can be provided. The reason for these wattage limitations is to prevent overloading the circuit. A 30-amp circuit is not suitable for supplying lighting units with ballast-type lamps exceeding 750 watts. If the total wattage of the lamps exceeds this limit, especially if all lamps are turned on simultaneously, the circuit will be overloaded. An overloaded circuit can cause the circuit breaker to trip, interrupting the power supply. More seriously, it can overheat the wiring, potentially leading to a fire. To ensure the safety and reliability of the electrical system, it's crucial to correct this code violation. The use of 400-watt medium-base high-pressure sodium lights on a 30-amp circuit exceeds the maximum allowable wattage for that circuit type, as per NEC 210.23b. The implications of exceeding these limits are not just about code compliance, they are directly related to safety. Overloading a circuit creates a risk of overheating the conductors, which can degrade the insulation and potentially cause a short circuit. Short circuits are a primary cause of electrical fires. Furthermore, frequent tripping of circuit breakers due to overloading can damage the breaker itself, reducing its ability to protect the circuit in the future. The heat generated by an overloaded circuit can also damage the ballast used in high-pressure sodium lamps, leading to premature failure and requiring more frequent replacements. The financial costs associated with these issues can be significant, especially in commercial or industrial settings where many such lights may be in use. There are several ways to correct this code violation. Firstly, reduce the number of lamps on the 30-amp circuit so that the total wattage does not exceed 750 watts. Secondly, replace the 400-watt lamps with lower wattage lamps that are still suitable for medium-base sockets, ensuring that the total wattage remains within the limit. Thirdly, install a new circuit specifically designed for the lighting load, providing adequate capacity and protection. This might involve running a new 20-amp circuit, for example, which, according to NEC 210.21, should not supply lighting units with ballast-type lamps exceeding 660 watts. Fourthly, use high-pressure sodium lamps with a different base configuration that is designed for higher wattage applications. These lamps are typically used with appropriately rated circuits and ballasts. It's important to consider the overall lighting needs when making these corrections. Simply reducing the number of lamps or using lower wattage lamps might compromise the lighting levels required for the space. A lighting design professional can help determine the optimal lighting solution while ensuring code compliance and energy efficiency. The National Electrical Code is updated regularly to reflect changes in technology and best practices for electrical safety. It's essential to stay informed about the latest edition of the NEC and any local amendments to ensure that all electrical work is performed in accordance with applicable regulations. Regular inspections and maintenance of electrical systems can help identify potential code violations and safety hazards before they become serious problems. This includes checking the wattage of lamps, the ampacity of circuits, and the condition of wiring and electrical components. Properly sized conductors, correctly installed overcurrent protection devices, and appropriate grounding are all essential for a safe and reliable electrical system. Remember, electrical work should only be performed by qualified and licensed electricians who are familiar with the NEC and local codes. Working with electricity can be dangerous, and improper installation or repairs can have serious consequences. In conclusion, the use of 400-watt medium-base high-pressure sodium lights on a 30-amp circuit is a clear violation of the National Electrical Code. By understanding the relevant sections of the code and taking corrective action, you can ensure the safety and reliability of the electrical system. Always consult with a qualified electrician to address any electrical issues and ensure compliance with all applicable codes and regulations. When dealing with electrical systems, it's important to understand the basic principles of electricity, including voltage, current, and wattage. Voltage is the electrical potential difference between 2 points measured in volts. Current is the flow of electrical charge, measured in amps. Wattage is the measure of electrical power, calculated by multiplying voltage by current. In the case of lighting circuits, it's the wattage of the lamps that determines the load on the circuit. The NEC sets limits on the maximum wattage that can be connected to a particular circuit size to prevent overloading and ensure safety. Understanding these basic concepts is crucial for properly designing, installing, and maintaining electrical systems. Also understand that different types of lamps have different characteristics and requirements. High-pressure sodium lamps, for example, require a ballast to regulate the current and voltage supplied to the lamp. The ballast itself consumes power, so the total wattage of the lighting unit includes the wattage of the lamp plus the wattage of the ballast. When calculating the load on a circuit, it's essential to consider the total wattage of all lighting units connected to the circuit, including the ballasts. The NEC also specifies requirements for the type and size of conductors used in electrical circuits. Conductors must be sized appropriately to carry the expected current without overheating. The ampacity of a conductor is the maximum current it can carry safely. The NEC provides tables that specify the ampacity of different types of conductors based on their size, insulation, and installation conditions. Choosing the right size conductors is essential for preventing overheating and ensuring the safety and reliability of the electrical system. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices are rated in amps, and they will trip or blow when the current exceeds their rating. The NEC specifies the maximum overcurrent protection for different sizes of conductors and circuits. It's crucial to choose the right size overcurrent protection device to protect the circuit without causing nuisance tripping. Grounding is another essential aspect of electrical safety. Grounding provides a low impedance path for fault current to flow back to the source, causing the overcurrent protection device to trip and to energize the circuit. Grounding also helps to prevent electric shock by providing a safe path for current to flow in the event of a fault. The NEC specifies requirements for grounding systems, including the size and type of grounding conductors and the methods of connecting to ground. Proper grounding is essential for protecting people and equipment from electrical hazards. Finally, it's important to remember that electrical codes and standards are constantly evolving. Staying up to date on the latest changes and best practices is essential for ensuring the safety and compliance of electrical installations. Continuing education and training can help electricians and other electrical professionals stay informed and competent. The use of 400-watt medium-base high-pressure sodium lights on a 30-amp circuit presents a code violation due to exceeding the wattage limits for that circuit as dictated by the NEC, specifically sections 210.21 and 210.23b. When addressing electrical situations like these, you should consider the specific details of the installation, including the voltage, current, and wattage ratings of all components. Ensure that all electrical work is performed by qualified personnel who are familiar with the NEC and local codes, and always prioritize safety when working with electricity.